We are separating oxygen from the air, just like how you would actually put oxygen propellant onto a rocket, and then we're feeding oxygen into our engine along with biomass to do this process so that you don't actually have any gaseous emissions leaving the system. I think we're gonna see a time, if we're not very proactive about this, where we can produce hardware much faster than we can get projects built.
Interesting. We're here in the HQ of Arbor with founder Brad Hartwig of Arbor, and we have some pretty cool stuff here to the right of us, which I've carefully framed out of shot just in case we need to blur a little bit of it. But we just filmed the main episode for S3. You guys talked in great detail about the system you're building and the problem you're trying to solve here. And for those who haven't watched the main episode yet, can you give a quick sort of recap of what Arbor is and is doing?
Yeah, we're at a high level, we're taking rocket engine technology and we're bringing it into the bioenergy space with the goal of creating carbon negative bioenergy. So we're developing a staged combustion, direct fired, supercritical CO2 recuperated Brayton cycle is like the full superlative. But at a high level, we're taking waste biomass and we're turning that into clean power that is free of emissions. And as byproducts, we create fresh water and remove CO2 from the atmosphere. And that last piece is really kind of the big thing, which is carbon negative energy we see is going to be the key to avoiding some of the worst impacts of climate change. The Intergovernmental Panel on Climate Change shows we can't only decarbonize the global economy, we need to actually draw down legacy carbon emissions. And so what we're doing here is really drawing down legacy carbon emissions while creating clean power.
So you talked about kind of the company's origin from that report coming out, and then you theorizing and your team theorizing what a good solution would be. Can you dive more into that on the personal side of things, what you and your co-founders were doing before, and your personal journey into this?
Yeah, so my co-founder, Andres Garcia-Clark, along with a lot of our founding team, comes from the aerospace engineering world. And so that was my background, which we started out at USC studying aerospace engineering. We actually were the first student group in the world to send a rocket to space, which is great to be part of as an undergrad. Went to work at SpaceX out of undergrad and helped develop and lead manufacturing for the Draco engine for the Crew Dragon vehicle. So it's the in-space propulsion system to ferry NASA astronauts to and from the International Space Station. And a lot of our early team did the clean sheet design development of the Raptor rocket engine that powers the Starship vehicle. And when I left SpaceX, I actually left at end of 2018, and my goal was actually trying to become an astronaut myself. Spent some time with the test pilots that were going to be doing the inaugural flight of Crew Dragon, and was really interested in going to space. So I left and basically started working on building a resume that would maybe be competitive for NASA astronaut candidacy. And that took me through a myriad of interesting jobs, everything from becoming an experimental test pilot for an electric aircraft development company in Mountain View, to becoming a search and rescue specialist, both with the California Air National Guard, a component of the Air Force, and the Marin County Mountain Rescue Team. And in search and rescue, especially on the civilian side, we would do disaster response work. And some of that is in Northern California, a lot of wildfire response. So our team would go in advance of wildfires coming through, try to get communities to take evacuation warnings seriously. And then on the back end, would go to these areas that were unfortunately devastated by wildfires and try to look for who didn't make it out in time. And seeing some of those effects up close and personal was very, very powerful for me, especially having grown up in the Bay Area. And it got me really thinking about my long-term career and where I wanted to spend it. And after spending a whole career trying to build machines to get people off this planet, decided I was going to pivot and focus really on saving this one, or Planet A, as we call it. And so started really looking at what was going to be, what are really the solutions that are available today that need to scale, and what are the technologies that we don't have that we need to develop quickly and deploy in order to avoid some of these effects. And so Arbor was really founded with the goal of mitigating some of the worst effects of climate change. And a key component to that, which is becoming increasingly evident, was decarbonizing the global economy is no longer enough. We actually need to draw down huge amounts of CO2 from the atmosphere. And those negative emissions technologies do not exist today, or they exist in some forms, but are not, they're not scaled to really where we need them to be. And even a lot of times we look at building the machine that builds the machine, that infrastructure is not there yet. So Arbor was really a clean sheet design, trying to figure out how could we draw down humanity's legacy carbon emissions from a physics and economics lens. And carbon negative bioenergy using rocket engine technology is really what we see as one of the most scalable solutions that could be developed. And so we started really with that clean slate. And 2 years later, we're having parts of the machine come together with a system that looks like it should actually do just that.
Wow, thank you for sharing that. I have so many questions. I guess my first is, I would love to get more insight into the starting clean slate from realizing that you needed to attack the problem this way, and sort of walk me through like the mind map of how you guys landed where you are.
Yeah, so bioenergy has been around as long as humans. It's like the oldest form of energy you think of is building a campfire that we're going to cook our food on with your fellow, cavemen. And so it's interesting because it's not a particularly new energy source. And there hasn't actually been a whole lot of innovation in the bioenergy power plant side of things over the last century. On the other side, there's been a ton of advances in modern manufacturing and engineering, and a lot of the techniques in terms of combustion, turbo machinery, a lot of that overlaps with the aerospace world, especially the rocket engine space. But when we look at bioenergy plants today, they're not cost effective. People in general are not looking to build more bioenergy power plants. And there's a lot of reasons for that. But one of the biggest is that just the price of electricity is not cost competitive with modern renewables. And what we're seeing is the value in the electricity is one thing, but the value in the carbon is actually more than the value of the energy. And so this is a resources play just as much as it is an energy play, which is that when you monetize the carbon, all of a sudden the economics kind of turn on their head. And bioenergy plants were not designed or optimized with the carbon in mind. They were really a traditional boiler, fed steam cycle is the more traditional system where you have a conveyor that's transporting biomass into a boiler that's heating up water, creating steam, and you're running that through a Rankine cycle with all the emissions going out the smokestack like a traditional plant. What we're doing here is we're developing a system that doesn't have any emissions. We feed biomass into the engine and out comes, of course, clean electricity, but we're doing a staged oxy-combustion process where we pull oxygen out of the air up front through a, say, cryogenic distillation process. That's how, just like how you would actually put oxygen propellant onto a rocket, you cryogenically distill oxygen out of the air, you load that into a rocket. We are separating oxygen from the air, and then we're feeding oxygen into our engine along with biomass to do this process so that you don't actually have any gaseous emissions leaving the system. You have just fresh water as a byproduct that leaves in a liquid form. And then you have pure CO2 that can be sequestered either durably underground, or you can utilize it as a feedstock for upcycling into new products. But in general, what we've seen in this space is that for the last 100+ years, power plants tend to be more of these sort of special snowflakes where each bioenergy power plant is its own unique design. It requires a lot of site-specific considerations and a lot of one-off engineering to build a project. And what that means is you have longer project deployment timeframes. You're a lot more likely to have schedule and cost overruns, all these things that impact the bottom economics and impact your ability to get financing. And also, just from a unit economics standpoint, it is trying to add carbon capture to one of these plants. That might work for an existing plant, but when you're talking about needing to deploy new systems, and you're looking for how are we going to actually reach the scale that is needed to hit terawatt scale power and gigawatt or gigaton scale carbon removal, that system, when you look at it from an outsider's perspective and you see the end objective, you realize that the system wants to look completely different from what's out there today. And so what that is a system that is modular, that is standardized, that can be prefabricated, so built in a factory and shipped to a site that's ready. You're trying to get your construction times down from what is normally 36 to 48 months. You want to get that to be less than a year, less than half a year if you can. Ideally, it's mostly in the site permitting, and then dropping off modules is actually a fairly quick process. And that is, there's a lot of cost savings that you can have when you're building out a factory that's able to do everything in a controlled environment and amortize the machine that builds the machine. So all of the, the infrastructure that you're using, everything from 3D printers to casting to the workforce that you need to assemble these systems, really trying to vertically integrate so that we can bring costs down. Another big thing is that the overall system, traditional bioenergy plants, the boiler operates actually at 1 atmosphere. And so you're feeding biomass into a combustor that's at 1 or even below 1 atmosphere. So from a safety standpoint, that you actually have any leakages are actually going into the boiler. And what happens is then you have plants that are the size of large buildings, or even a small town is the overall size of the plant. What we're really trying to do is shrink the size of all the equipment so that you can take advantage of modern engineering and manufacturing. And so by doing systems at much higher pressures, we see we have a path to a system that is an order of magnitude, even 2 orders of magnitude, smaller footprint for the same throughput. And that's now something that you can, or we call it like hardware you can hug. You can get your hands around it, and this is stuff you can build on skids and ship on standard Class 8 trucks to a site to build a project.
You guys share a lot of technical detail, which is great. And I'm curious what you feel like people don't ask enough about when you're giving people tours of Arbor or talking about the company, what you wish people kind of thought about a little bit more when you're talking about it.
Yeah, I think we're trying to develop a technology that has never been developed before. What we see is building a company in the deep tech space has its own unique challenges, and that's everything from dealing with hardware that costs a lot more than your traditional software. We also have to build, we have to build factories. We have to build test sites that are able to test the hardware that we're building, and that's a lot of work. I think there's, coming from a company, even like SpaceX, you have this giant machine that's already set up and building and working, and it's I think that 0 to 1 stage when you're trying to build a team and you're trying to put the systems in place. That stuff it takes just as much work and attention and focus as designing the actual machine. And I think what we're doing is where things run into the real world, where you're looking at actually putting projects down, and now you're having to work with not just industry but also governments, and we're trying to do something that has a lot of positive impact at a planetary level, but we also have to pay a ton of attention to what benefits do the local communities get where we're deploying these projects. And I think that's something that we see again and again is there's a lot of interest in action towards everything from reshoring American manufacturing to bringing more renewables online. Is there's a lot of interest in this stuff, but oftentimes you have groups that are very excited about that next wave, but they don't necessarily want the jobs, they want all of that coming to their area. But when you talk about actually building a project, breaking ground, and having something that's going to be there for a long time, that's where you end up with things starting to slow down, because you have a lot of people that are very excited about progress and moving the needle forward, but you also have to contend with all of the impacts that you're going to have in that more immediate environment. And so we actually spend a lot of time thinking about how we can benefit the local communities in which we're building projects. And this is everything from, can we reduce the price of electricity for customers in the area, to, hey, these agricultural residues are normally pile burned right there on the farm, which create local air pollution. If we take that material and run it through our system, that pollution goes away. To, of course, job creation is always, I think, a big point of interest for groups. But I think as we start to look at growing industrialization needs, this is going to be something that we're all trying to figure out together, is how do we make sure that we're able to build systems, build factories, build projects in a way that works with the communities so that we get increased acceptance. And how can we, I think we're going to see a time, if we're not very proactive about this, where we can produce hardware much faster than we can get projects built.
Interesting.
And so that's an area that I think there's a lot more almost grassroots work and engineering, almost social engineering, that needs to get done and figured out to reduce some of the friction of, okay, we can build these machines and it can do these amazing things, but how do we now get them out into the world in a way that we can really have the impact that drives change?
That's such a rare take on the sort of issue of the carotting of the sort of veins and arteries of the country and building things. I haven't heard. I'm curious, like, what led you to that opinion, and why do we need to do social engineering to even do that? Like, why don't people just get that this is important stuff to do to catch up with other people who are leading?
Yeah, we're seeing, some people call it the electricity gauntlet on, the power side, which is, there is a rapid increase in the need for electricity and energy across the board. And that's everything from ramping up manufacturing to the rapid growth of AI, and especially training for LLMs and beyond. Huge electricity requirements. These companies in the country have also set extremely ambitious targets for their emissions in 2030, 2035, and beyond. The goal is, President Biden has set the goal that by 2035, the US is carbon neutral. And there's this problem where you have, there's cheap renewables that can be deployed, but they operate at a low capacity factor. So maybe 30% capacity factor. They're not on most of the time.
Sure.
And the other things, nuclear, geothermal, have a lot of headwinds politically in getting new reactors online, or even getting them approved through the existing regulatory bodies. Even with wind projects, you see that there's a huge interest in wind projects, but no one wants those undersea cables to be going through their beachfront property on the East Coast. And it's one of those things where it's hard to argue with the fact that infrastructure is it's big, it can be ugly, it can change what you are used to. If you are looking at building pipelines or looking at building projects that are going to expand into areas that are prior ranch land, or even sequestering CO2 underground where it's going to be out of sight, out of mind. I think a lot of people, there's still mistrust for what are maybe deleterious effects of technologies. I think there's a lot of education that needs to be done at the community level. But I think there is just in general a natural resistance to new development because it will inherently mean change. I think there's a lot more work that companies are going to need to do everything from improving literally the aesthetic of infrastructure that goes out into the world to improving the narrative around what truly are the benefits that are going to be driven into the communities where the systems are actually built and operated. And how do we make groups want these projects? How do we walk them through all of the benefits that will be flowing into their communities? Because if the direct communities are not going to be seeing benefits of the projects that are being built, then the first question is why here? Why not do it somewhere else? And I think it's easy to show on paper things that will work, but until you are actually boots on the ground, chatting with the communities and seeing like, what do you guys really care about? Like, why would you want a project here? Why would you not want a project here? What can we do that will make, your lives better on the other side of this project being built? And that's something that is, at least so far, it's every community is different. There's some things that are maybe, across the board, communities want to be heard. They want their feedback to be to matter and to be taken into consideration. But it requires a lot of individualized attention at the community level that I think a lot of industry has not had to contend with in this way in the last 100 years. Just the scale of deployment that we're talking about is something like we've never seen before.
Totally. It's interesting hearing you talk this much about getting communities' opinions and figuring out the why behind they might have a objection to building important things in infrastructure. It's also interesting during the main episode, your co-founder talked a lot about kind of like thinking about that you guys are doing this for your kids, right? And this idea of like, this is really freaking important to get right. And I often think about in the lens of S3, like how do we inspire more people to care about all the cool technology that's being built, applying it, making the world better, and inspiring more people to work on this kind of stuff. I'm curious if you have any meta thoughts on that idea.
Yeah, Arbor was in part in the early days, really an experiment to see, or there was a large experiment, which is folks that are working on developing rockets. Yeah. That's one of the coolest missions out there, is trying to make humanity a multiplanetary civilization. And will people be just as excited to work on other problems that are here on Earth? I think we have a privilege in that what we're doing has a lot of overlap with technologies that are used in those spaces, and we are able to pull pretty directly from those talent pools. And what we're seeing is a lot of really talented engineers are interested in working with good people on hard problems, wherever that is. And so it's really just equipping them with the resources and the other team members to do that. But it is definitely, when we think of training the next kind of wave of talent that's going to be needed, it starts early. And it's, we think of even, is middle school like the right, time to be targeting some of these groups. And it's yeah, probably like sometimes, by late high school, it might already be too late.
Yeah,
Um,
it's a harsh reality. I think that's actually very true.
so I think there's, of course, you can pivot into a lot of these industries, but I think the big thing is we need more people that are going and studying STEM fields. So science, technology, engineering. Um, I think what we're seeing is the problems are becoming more complex, and it really helps to have an understanding of not just the technology and the engineering, but also the other side of it, which is what is what is going to be adopted. It understanding kind of where the world that your product fits into is really important. Um, yeah, I think there's so many different aspects. Like we could go into so many different directions for this question. I don't know if there's anything that you're looking.
I guess more so, there's sort of two things I'm particularly interested. One is like I think a very small percentage of America specifically is really interested in building the future. A lot of people
Yeah,
think technology is bad or negative, or just doesn't realize that like we're launching rockets pretty much every other day,
yeah,
and that like people with relatively low amounts of capital and like risks can like go and build crazy important things.
yeah,
And to me, this is like cooler than like basketball or sports or like I don't know, but it feels like there's like a lack of excitement about it outside of engineering communities. And
yeah,
so my whole like question is like, how do we inspire that? Is it worth it to inspire that? What do we do?
yeah. I think there's a quote from a movie I love that is just engineers make dreams a reality.
Yeah.
and and to me that is what got me so excited to become an engineer in the first place. I was, again, I think back in middle school debating between engineering or architecture, but I wanted to be a builder because I loved the idea of being able to have an idea and start sketching it out and then actually bringing it into the world.
Yeah.
And engineering is really one of the only fields that does that. I think the future for me, technology is actually almost an antidote to a lot of the fear people might have
Yes.
about where the future is going.
Yep.
And for me, it's a lot of people hate on fossil fuels and things that we've come to realize the massive impacts on an environmental planetary scale kind of level. But it is hard to argue with that fossil fuels have drastically improved the quality of life for the vast majority of our global population. And technology is going to be critical to getting us out of some of those sort of, more consequential bad effects of fossil. But the world is, I guess, we live in the kind of the most peaceful and exciting time that there has ever been. And yet I also think looking to the future, it's only going to be even more exciting and more peaceful if we continue to invest in technologies that can get us there. It's definitely it. I think there's to really build machines that have the ability to change the world in a positive way. It requires a almost insensible optimism for what the future can be, and it requires having a vision for a future that you're excited to live in.
Yeah.
And then it's really just once you can imagine what a future could look like, then it's just a matter of getting to work and getting people on board that are excited and can build off of that same vision. And oftentimes, where we're going is something that none of us can even imagine, but it is having, kind of the audacity to think that there is a future that is better and that you can meaningfully contribute to making that happen. Engineering is really what I see as the only way to build that future. Now, I say the only way. I think there's, of course, all of the social aspects of this as well. And I'm very excited to see a future wave of engineers that are also really informed about the social aspects of technology deployment as well. I think that's going to be increasingly important both for design and for adoption. But to me, it's just like, yeah, multiplanetary civilization is just, I think, objectively far more exciting. And I think having a world here on Earth that is based on our resources being circular, where we have, we're able to recycle our resources and continue to build rather than having a kind of one-way trip from extraction to landfill. There's just so much value that's being wasted there. And yeah, we're excited about really kind of like this solar punk future where the only way that humanity continues to progress is we have to become a sustainable civilization. It's like if you're not a sustainable civilization and you're extracting resources faster than you're replenishing them, then you're inevitably you're heading towards your demise. And so we need to, it's almost like becoming a sustainable civilization is the foundation for a spacefaring civilization.
Yeah.
It's the foundation for improved quality of life for billions of people on this planet. And yeah, we're trying to make that happen.
What do you think most deep tech startups in general are getting wrong in their approach to building the future?
I think there's some very difficult decisions that have to be made early on at a company. And some of that is the scale that you decide to operate at. And I think what sometimes is really difficult to do is you need to have a really big vision because that's what's going to get people excited, not only to give money, actual investors, but also people that could potentially join your organization. Engineers in general, we want to be part of something that's larger than life, something that is going to be much bigger. And it's interesting because I think the weird paradox is that you need to have this larger than life vision, but you need to be very careful, tactical, and calculated in how you're going to get there, which is you need to actually usually start very small. So you need to have this massive vision, but you need to be very practical and start very small so that you can actually get there. Because everyone gets excited about a big vision, but you can't just go right to building that vision because that is too expensive. And so it's finding those more bite-sized pieces and making sure that you have a clear path to get to this large vision, but with steps that you can start tackling today with limited resources. Because I think in startup world, you're always contending with the fact that you don't have as much resources as you want, whether that's capital, whether you'd like to build a larger team so that you can move faster, whether you'd like to have quicker access to test sites or infrastructure or customers. You have literally just a bandwidth on your attention and your focus, and that is especially high in the early stages. And so I think this balance of having a massive vision but small incremental steps that you can take now is really sort of the space that you need to be operating in. And so we see people get that wrong where it's big vision, but they're going to start big also, and they need massive amounts of capital. Like your minimum viable product requires you spending, $100, $200 million to get to, or more. Or the other side of it is having too small of a vision, being practical, but too small of a vision. And in general, those I think usually fail as well, or they end up maybe being acquisition targets, but it's not necessarily, when you become an acquisition target, then you get swallowed by really the vision of the company that you're getting acquired by. And so you lose that ability to oftentimes have the impact that founding team's vision is based upon.
Awesome answer. I like that. This next question might sound a little weird, but I think it's really cool to ask engineers and founders this. Can you try to describe how you think? And what I mean by that is, do you have any mental models or lenses you commonly use to look at problems or the world?
Yeah, I think the first filter is usually always a physics one, and that is really just, yeah, from a physics standpoint, is what you're trying to do possible. That's, I think, a very it's an important filter, of course, just because it's it's you need to get the vision right in terms of you're when you're looking to start a company, you're inherently when you're starting a company, you are by definition not starting every other possible company that you could have started.
Yep.
And and so from a thinking perspective, it's wanting to really make sure that your initial vector is right.
Yeah.
And so, I use physics as a filter to look at a lot of different options and see um, what is the best this thing possibly could be.
The global maximum, so to speak.
The global maximum, so to speak. Where do you run into constraints that are, from fundamental physics? Where do you run into constraints that are, increasingly at the planetary scale? What are what are you going to bump into when you start to design this thing, when you start to deploy it in the world? Um, I try to get that fundamental physics laid out fairly quickly, but then you have to go talk to people. And I think what happens is if you just stop at the physics, there are a lot of things that look great on paper that have no real chance of working in the world where the rubber hits the road. And that is knowing where you're crazy and where that's a good crazy versus a bad crazy. I think getting a lot of input is for me, it's like as a founder, your job is to get a bunch of opinions and a bunch of outside ideas and then pass it through your filter and then try and make a decision that might be against all of those pieces of feedback you heard. Maybe you actually feel you're onto something. But I think it's, yeah, first is physics lens. Second is an economics lens. So how does this, I think realistically, like key economic drivers are how the world operates. And most innovation comes out of a capitalist country like ours that is extremely motivated by the ability to continue to build capital. And so it's physics lens, economics lens. Yeah, I think honestly, something that I get really excited about that I feel like always finds its way into the thinking process is I'm a very visual person also, and so it's oftentimes like, what is this thing going to look like?
Sure.
And is this exciting enough?
Yeah. I had a friend ask me if I thought there's other drivers that would be better or different than purely capitalistic or economic ones to drive innovation. I'm curious to get your take on that.
It is interesting. I think like people talk about capitalism as being the worst form of government that just happens to be better than all the other forms of government. And so far we haven't seen anything that works better than that in terms of driving innovation. I think something that is meaningful at a startup is the ability to for people that are joining the startup also be able to own a piece of that startup in the form of equity. And that allows you to have some kind of notion that if this is successful, I mean, we're talking about potentially like generational wealth that you could, bring, and maybe it's 20 years from now, but maybe your kids are set up in a really good spot. I do think though that in general, really talented people want to go work on the hardest problems, and they want to work with the other best and brightest engineers. I think that is something that a lot of folks would forego an opportunity that has the potential to be more lucrative in order to be at the front lines, pushing the boundaries of a space that has meaningful impact at the global level, um, and work with other brilliant people that they can continue to learn from. I do think that the financial piece needs to also be there in most cases still. It's a Yeah, it's a really tough question. Yeah, I think in general there is a big part of it that is the future that you're trying to create. And I do see there almost being some exchange, happening, or almost competition around which is the future that we should create. And in a sense, when you join a company, as when you're kind of playing your cards and you're saying, "Hey, I'm going to sign up for this company, and this is where I'm going to work," you're kind of signed up for that version of the future as well.
Yeah.
And so I think people, say a lot with where they choose to put their career, because as we start to see more and more that this is the domain where the future gets built, it's really, okay, well, which version of the future? Okay, I vote on this one. And I want to not only vote on that, but I want to be able to help craft that version of the future as well. And I think that, in a sense, it's building that more beautiful, more exciting world. Getting to be a part of that is, how do we retain that? Um, I think that's really one of the bigger exchanges. There's the currency aspect, but there's like the vision and future creation aspect of it.
That's a great lens to look at it through. Awesome. My last question for you is it's a little bit another weird one, but I think it's again cool to ask founders this. What is your current life philosophy?
Man, I think my philosophy, there's so many directions you can go in this too.
It's intentionally open-ended.
Yeah. I think like fundamentally I think a company is oftentimes a representation of your own personality as well. And
Yeah.
what we're doing here, I think lies at this intersection of technology, nature, and people. And I'm definitely a firm believer that if we're very intentional, the future can be much brighter. It can be a lot more sustainable, that as people, we can be a lot more connected, that we can have a bigger respect for the resources and environment that we're blessed with. I am going to pretty tirelessly just push towards making that happen. Um, I feel like a lot of times there's and I guess I think that to be a founder in general, you kind of have to be a bit of an optimist. Um, I think we're trying to be very cautionary and calculated in terms of execution, but in general, I'm a pretty big believer that there's a more beautiful world on the other side of this that we can continue to usher into existence. And I think, philosophically, I like to think that people are generally good, and that in general we will continue to find not only the best technologies out there, but really the best use cases for those technologies. And I think at every level there's I think humans are naturally builders, and we're going to continue to build. And I think we're very interested at experimenting. But I do think the goal is always, how do we make things better than they are now? And we're very interested in continuing to build and build systems and processes and structures that allow people to continue to do good work and continue to build a more positive world.
Great answer. Thank you for taking the time to do this, and thanks for building Arbor. I'm excited to see watch you guys grow as you go and change the world.
Awesome. Well, thanks so much for coming.
Yeah, this has been a great interview.
Great.
Thank you.